Hi, welcome to the Signal Pad. I have another repair video for you guys, and this time we're going to take a look at this Stanford Research Systems model DS345. This is a 30 megahertz synthesized function generator, and these things are actually not that cheap. With the options this one has, they're almost $2,000. And I bought this broken from eBay, and before I start repairing it, I want to thank my Patreon supporters. You are the reason why I'm able to afford and buy these broken equipment. All the funds that come from Patreon go back to the lab, and I'm really grateful, and I'm looking for more ways to give back to my Patreon supporters. I have given equipment away, and there will be more of that in the future, and I have some other ideas, and we can discuss that during an AMA, a video later on. So this particular unit apparently has a couple of different problems. Some of them are pretty straightforward, like it has a bad power button that's flaky, that's obviously easily fixable, but it also has, according to the listing, it just shows the completely wrong frequency, that the frequency that's coming out of it doesn't match what's on the display. And the frequency is not stable with respect to the fact that this one is supposed to have an oven-controlled crystal oscillator, so they expect a certain stability from that oven, and they're not getting that. That worries me a little bit more, because it could be that the oven crystal is broken. But either way, these are the issues with it. So we're going to have to power it on and see what's going on with it. And they told me that someone had tried to repair it, maybe they've done some work on it, but they're not sure, they weren't sure about that. And that worries me also, because I have no idea what state to find it in. So, well, let's turn it on first, because it's supposed to turn on, and normally if something does turn on, I tend to turn it on and figure it out. And let's see what it does and how it looks like, and then we can go from there. All right, let's take a look and see what happens when I connect it to my Sencore variable isolation transformer, which is in the background. I know it's not in focus at the moment, so I can change the focus and try and get the focus on that, so we can turn it on and see what kind of current draw we have from it. There we go. Let me try that on. What do we get here? There we go. So we are burning about 12 or 13 watts. So that definitely means that it must be consuming something through the oven. So this one does have the oven option, so it must be burning some current through that. So it's kind of promising, I guess, the oven is on, and this is going to burn this standby power no matter what, because they want to keep the oven hot so that it increases the lifespan, is also ready to go whenever you turn the synthesizer on. So let's go ahead and turn the synthesizer on itself. Hopefully we can refocus back on the unit. There it is, and let's see. And there we go. You know what? Actually, the button wasn't too bad. Seems to be working fine. Let's see what it says. A bunch of numbers passed by. I'm looking at the center. Yeah, the button. It seems okay. I don't know what they were complaining about. Yeah, that's a lot of zeros. So it's set to frequency 0. Interesting. Well, this unit is supposed to have a 1 microhertz resolution and a 1 microhertz lowest frequency setting, but this is actually set to 0. That's pretty unusual. Amplitude. Oh no, this is not. No, the buttons don't work. Come on. Oh, these buttons do work. Why are these buttons not working? That's unpleasant. All right. Well, these ones, these guys seem to be working. Yep, no problem there. And what about the numbers here? Let's see. Yeah, the numbers. Oh, what happened? Oh, there we go. That's a lot of zeros. Why is it that I can enter all zeros? Okay, no, I can't. Then why does it go back to zeros? It's doing some weird stuff here. Well, it does seem to turn on, so I guess let's just connect it up to an oscilloscope and see what's coming out of it, and see if it's anything being produced. I wonder how they tested this, given that you can't change these, and what's the point? All right, anyway, we're going to have to investigate further. Let's hook it up to the scope and see what's coming out of it, if anything at all. All right, let's go ahead and take a look at the outputs. I have connected the sync function and the output main function of the instrument directly to my Keysight MSO S-Series oscilloscope. So here we can see exactly what the waveforms are going to look like. So let's go ahead and turn on the instrument and see what happens. And here we go. All right, so now the sync function is on channel 2. That's the green one. So right now it's doing some weird things on the sync. And there it is. Hey, it looks good. It's doing something. Yes, it's producing some kind of a waveform. It looks like a reasonable amplitude, about 1 volt peak to peak, and the sync function is quite large. So it's good, but let me see what the frequency of this guy is. 30 megahertz. So it's at the upper frequency range of the instrument. But of course, we see 0 hertz here, and this is indeed set to frequency. and it is 2 hertz. So I don't get it. Let's change the frequency. So let's say I go, let's say I want to enter 10 megahertz. So I would say, well, this is megahertz, so frequency. I cannot do anything here anyway. So yeah, see, as soon as I press this, it disappears. I don't know, 10. Oh, okay. No, that's not what I wanted. Megahertz. Nah, frequency error. Something is weird going on here. Why is this doing this? Okay, let me just enter, I don't know, 1. 0, 1. No. Let's say I want to do, maybe it doesn't like the ones. 5. No, does the same thing. Oh, I did it. I get it. Oh my God. I bet you guys were screaming at the screen. I get what's going on. These 2 digits aren't showing up. That's why when I press it, it's here. Then I press it again. Or I should say it's here. Then I press it again and it's here. And then when I say megahertz, now it says, it looks like it says 1 megahertz, but the output is 11. There it is. See, that makes sense. It's doing 11 megahertz, even though it's saying 1 megahertz, because this digit isn't working. And that's probably why these buttons don't work. It must be divided into sections, because these are switched, right? They're scanned. So during the scanning, they may be sharing some lines, and that's why these aren't working. So this section is dead, whereas the rest of them works. And in fact, you know what? Now it makes more sense. Look at this. Look at this. I turn it on. It says sting. I'm sure it's not talking about the singer. It's supposed to say testing. So that's why this is going on here. That makes sense. All right. That is, oh, something else happened. NCC pre-error. I have no idea what that means. No idea. Oh, now it's giving an error. It wasn't giving an error before. Something happened to it. Testing, yes. No. I wonder what this could be. NCC. Nope, no idea. No idea what that could be. And of course the button doesn't work. So let's say if I go 1 megahertz. Let's see, 1 megahertz. Yeah, it does do 1 megahertz. There it is. You can see it. So it is producing, I don't know what that error is at the beginning. It wasn't doing that before. That's a little bit concerning. It's slowly breaking down. We're going backwards. This is not what I wanted to do. Yeah, I mean, I'm going to have to investigate a little bit more what that could possibly mean. NCCPRE. Let me go to the manual. I think there's a service manual, and I should be able to get the schematic. Let's figure out what this means first. That should be a good start. So it turns out, based on the manual, this is supposed to be saying sync CPR error, which means that the sync generator does not produce a full-scale output, which is a little bit strange because the sync generator, this port coming out here, is in fact generating a full-scale output, because the full-scale output should be 2.5 volts, and it is in fact 2.5 volts. So it is doing it, but it for some reason thinks it is not doing it. Now I don't know why it happened after it warmed up. Maybe it has multiple issues. It looks like it has got some weird cascading failure going on. But either way, let's open it up, take a look. I do have the schematic. Let's go to the schematic, isolate this part of the circuit, figure out what it is connected to, and then see if we can find the issue with it, and then we'll take it one step at a time. That's the most we can do at the moment. All right, I've taken the top cover off. It's very nice. Clean design, as you can see, pretty old PCB. All of Stanford Research stuff is uses quite old technology. They don't really change their designs very often. And so we've got a fan there, the main transformer there, and I can lift this up. Oh, it's plugged in. Hold on, there's a little connector there. I need to remove this, I think. There we go. And ta-da! There it is. Looks pretty nice. And this is going to fall over, so I'm going to put something behind it. Let's see if this would hold it. Perfect. There it is, and looks nice, clean, interesting. And there's our massive 10 megahertz oven-controlled crystal there, which is coming from this cable. It looks like it. Interesting that they're passing the RF signal. I'm looking down in there, and they're passing the 10 megahertz from this weird cable too. No coax, no nothing. It's a little bit surprising, especially because of its proximity to the transformer. It's a little bit unusual. And we can see a lot of through-hole parts. My goodness. There's so many of them there, and this top board here looks like some additional circuitry. Looks like some more advanced components on this one, the 10 megahertz reference enters this top board here, and you have to do some reverse engineering to figure out what's going on there. But the architecture is fairly straightforward. All the DC stuff's down here. All the voltage regulators are screwed to the chassis on both sides. So we have to take a look and find out what's going on. So this ribbon connects the front panel over here. Let me see what's going on here. We've got a bunch of components there, and this ribbon is right next to it. So perhaps in this area is where the problem is, and we're going to have to figure out maybe one of the driving ICs is bad. So yeah, at this point, I think the best thing to do is to take a look at the schematic, so we have a place, an actual location to look into and figure out what's going on with it. And here we are with the schematic of this unit. So you can see a whole bunch of stuff here. This is where the main AC line comes in, and we have our various voltage regulators generated over here. So by the look of it, these voltage regulators should all be fine because we do have a functional device otherwise. So let's go forward until we see where the front panel control circuitry is. This portion here, what is this labeled as? DDS microprocessor system. So microprocessor control is over here. Let's forget about that. And what do we have here? This, oh, there you go, DDS display, lamps and keyboard. That's what we're looking for. So let's see, what do we have here? So we have a whole bunch of ICs here. These 74H series, these all seem to be controlling even and odd, and lamps, I guess they mean LEDs. So there's some even and odd matrix of lines that are scanned and switched. And it looks over here, we have the strobes. So strobe 0, 1, 2, 3, 4, and 5. Connected by a bank of transistors and resistors connected to another 74,000 series logic there. So nothing unusual about the way this is done, very, very traditional. So it looks like, well, given that we don't have a section of the keyboard and a section of the display, we must be missing a main line, like maybe one of the even and odd lines or maybe one of the strobe lines. But given that I don't know which LED section is which, let's go and see if we can find the front panel schematic. This is not it. None of these is relevant. DDS output amplifier, nope. And then we're going to have to also take a look at the sync output at some point. There's an A to Ds, D to As, blah, 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 clock, reference. We have to look at the reference also because apparently the reference doesn't work. First accumulator, DAX. These are all useless. Useless information so far. Oh, lots of, there you go, a lot of lamps. There's a lot of LEDs. I wonder what display unit. Okay, there it is. There you go, sine. Okay, these are all the lights for the different sections. There you go. So sine, ramp, square, noise. These seem to work. These are fine. The keys don't work. So some of these keys don't work. What is it that doesn't work? The frequency key doesn't work. So what is that? There it is. No, function. That's not it. Size, mod. No. Where is it? Where is the frequency key? There you go, amplitude frequency, there it is, key 0. This bank doesn't work. This bank is controlled by this line goes STB5, strobe 5. So strobe 5 seems to be not working, because if strobe, but then that would mean that sine and ramp and square shouldn't be working either, although I didn't try it to be fair there, but it looks like at least this is a good place to look. Oh no, I'm sorry, I take it back, strobe 0. So strobe 0 is this line, so there it is. So strobe 0, let's see if that is consistent with these digits. If this is lined up the way the display is showing up, then that would make sense. Strobe 0 also controls the 2 first digits of the LED panel. So this is so far consistent. These two don't work, these keys don't work, and they all share strobe 0. So let's go and look at strobe 0. We come all the way up here, back to this. I hope this is not giving you guys a headache. I'm getting a headache. Strobe 0. Where is strobe 0? There it is. Strobe 0. Q306, R305, and then U306. There we go. That's one place to look. So it is possible that this transistor is there. That would be a pretty easy fix. I mean, a 2N3467, easily we can replace this PNP. That would be a great problem if that's it. And then a resistor, and then we have 74H CT374. This could also be bad, but it's not very likely that this is bad, given that all the other strobes are working because the rest of the LED screen is working. So it can't be these. or maybe just one channel is bad. That is also possible. So let me go ahead and take a close look and see we can measure this. We should be able to even use an oscilloscope to look at these strobe lines and see if they're there or not. That's a nice place to start. So I came back and I found immediately the bank of the transistors, that is the transistor set that we were talking about. So let me zoom in, and I also found something else that was pretty amazing, and I'm sure you're going to notice it as soon as I zoom in there. I'm sure you already see it. So I came in and I was trying to figure out which of these transistors was the one that was suspect, and if you remember, it was Q306. So I was looking at Q306 and I noticed a very small line on this resistor, and I used my pliers, and as soon as I moved it, it broke apart. You see that? And it wasn't as bad as this. I did some damage to it right now, but before I started recording, but it had a little line on it when I was looking at it zoomed in through the camera. And as soon as I touched it, it cracked. Now, this series resistor is a resistor that drives the base of Q306. So if this is broken, naturally Q306 is not going to get a signal. It's unusual to find a broken resistor. I have seen it in the past before when they're burnt. So I wonder if this was burnt for whatever reason. So we can't really completely eliminate the fact that Q306 is bad. But either way, it immediately broke. It might have been, partially broken or damaged, because the value of this resistor isn't very critical. So let's say it came back from the factory, instead of being, what is it supposed to be? It's supposed to be 150 ohms. Let's say instead of 150 ohms, it was 600. It wouldn't really matter that much. It would still most likely work. So yeah, so this is a good place now for us to figure out, and maybe we can replace that and see if it helps the situation. I will make a quick measurement on this to make sure that's not shorted to ground, the base of that transistor, and then we have a place we can turn it back on and see if we get our digits back at least. And here's the back of the unit, so I'm going to have to look for that resistor, find out where it is, unsolder it, and I did find the replacement. This is not exactly the same value. This is 140 ohms versus 150 ohms, but it wouldn't matter so much. And let's go ahead and replace it. I'm eager to see what happens. And here we have the replaced component. I did check the Q306 over here, and it's fine. Doesn't seem to have a short on any of its terminals. And this resistor, you can see, is a little bit different from the other ones. And yeah, so let's go ahead and turn it on and see what happens. Okay, one more try. Here we go. And there it is, testing. That's what I'm talking about. No more sting. Test passed. Okay, and it passed. I don't get it. Why wasn't it? Why was I getting that other error? I can't see how the display error would have anything to do with the other error we were seeing, the CPR error, whatever, the sync error. But these buttons should work now, and of course they do. Frequency error, that's normal because you can't do a square wave at that frequency. So there you go. Now when I press the first number, that's it. That's what we were missing. So now it makes sense. 30 megahertz, and it will show up. So if this digit is gone, then we would see all the zeros. So it looks good, and yeah, it seems to be working. So now the other issue is let it run for a while and see if the sync function stops working. And I'm going to connect these two back onto the scope, and we can verify that the frequency and everything is correct here. So this is 30 megahertz, and let me refocus onto the oscilloscope so we can test a couple of these functions. Okay, let's try a couple of these things. So right now, 30 megahertz sinusoid is working. Let's change the amplitude. So it is set to 1 volt peak to peak. Now I can set it to 2 volts peak to peak. And indeed, it works. And the sync is working. So the sync is kind of annoying. Let me turn the sync off so it's not in front of us. And let's go back to the frequency. So I see no issues with the frequency. Setting it to 1 megahertz should work quite nicely as well. And indeed, it does, as you can see. Let's try square wave. Nice square wave. Triangular wave, it cannot go as high of a frequency, but it is doing a nice triangular wave. It's 100 kilohertz right now. And a rising ramp, noise, and the arbitrary waveform, which is empty because there's nothing downloaded into it. And yeah, it looks quite nice. I'm happy with it. Let's see if the modulation works. So right now we are, let's try something low frequency, something fun. So here's 1 kilohertz. Here's our 1 kilohertz signal, and I'm going to do a sinusoidal modulation Let's do an FM modulation and the rate 1 kilohertz. Now we should be able to make a dance. There we go. We can make a dance. So it's definitely working. The modulation is working. Of course, the reason it's doing that is because I'm doing an FM modulation, which is equal to the carrier. So it looks like they're dancing. It's kind of fun. Yeah, looks good. I think it's working otherwise. Now we have to investigate what the issue is they were talking about when they said the frequency wasn't stable. So let's go ahead, and for that we cannot really use the oscilloscope here. We would have to go to a frequency counter and measure it there, and at the same time we're going to let it run for a while to make sure that it is stable. So there was an issue with the frequency stability. I actually traced it and I found the problem, and unfortunately accidentally erased that little portion of the video. But I'll tell you what I did. It was only maybe 5 or 7 minutes of footage there. But I'll explain to you what was going on. I looked at the 10 megahertz output at the back of the unit, and it was, reasonably okay. It was working. But then when I looked at the frequency stability at the output, it would jump back and forth. And to make matters worse, when I closed it up, it would be different than when it was open. Then I noticed that when I close and open the screws to this board, it would change. And when I turn the board to its side, it would change again. Then I noticed that the 10 megahertz reference from the main crystal is connected to these pins over here. This is a connector. If you remember, when I lifted it up, there is right underneath it is the wire that goes directly to the 10 megahertz reference. And by following that 10 meg, I found out that there was a break in the line right next to that screw. And actually, it may have been caused even by me. I'm not sure. But right over here, you can see I've done some patchwork here. This line I've replaced. And you see it's so close to that screw. And I may have done it when I was opening and closing it. That's why it was intermittent. So the frequency seems to be stable now. And it's fine. And you can see I'm generating here a 10 megahertz signal there. And if I look over here on my frequency counter, you can see it's pretty stable, and it's pretty accurate also. This has been calibrated a while ago, so it may not be completely accurate, but it is off here by about 24 hertz or so. So it's okay. It could be calibrated again and perhaps then readjusted, but I'm fairly happy with that for the moment. But the issue that we were seeing with the sync error, that issue is still there, and that issue only shows up when the unit is warmed up. It doesn't show up when it initially powers on. So let's try it again. It's been running for some time now. Let's turn it on again. And yeah, there we go. You see sync CPR error. So yeah, that issue is still there. So we have to go to the schematic and find out what is raising this flag and whether it's something that we can address, and then we can go from there. So let's see if we can figure out this issue with the sync. So here's where the sync comes out of the instrument, and there is a buffer here which is going to create a 50 ohm output driver. Now there is nothing in this circuit at this point that detects whether the signal is the correct level at all. Therefore it cannot be done at this point. So I have to keep going further back. If I go further back, I reach this component, which is a selector. So it selects between the sync and the trigger out. So still no way to detect whether the sync signal is actually working. If I follow the sync here, it goes to one of the ribbon cables. So I have to find the other ribbon cable. Now we continue down to find the other ribbon cable, and the other ribbon cable is over here, which then ultimately the signal sync is taken from here. So now we have to find that signal, the signal sync. So we're going to keep looking for that somewhere in the schematic, and I'm going to come across it at some point. There it is. So here's a sync signal over here. Now this sync, it comes through this buffer here and is generated by this comparator circuit here and this differential level shifter here. So it's not really important at this point because it's still not a way of detecting whether this sync function is actually doing anything. So we have to keep going around here, which means the detection must be done somewhere else after this portion of the circuit, because this sync is replicated in this part of the circuit through this differential pair. So this differential pair output is level shifted and comes through a relay here and then goes into this IC 8834. Now before it goes in there, there is a potentiometer here which seems like it adjusts perhaps at the threshold where this detection is being made. So I took this and I played around with it just a little bit, because remember this error was intermittent, it would come and go. So it is possible that this potentiometer has now a cold contact and it's not making good resistance that it's supposed to have. So I just wiggled a little bit to break that connection and hopefully make it better ohmic contact there. and I just adjusted a little bit, and monitoring these outputs made sure that they indeed toggle depending on the level of the signal coming in. So I made some modification there, but let's continue on. Now we take these two, and these two end up somewhere else in the circuit, so let me find out where that is. And those two ports are taken somewhere else. I am going to find them, I hope. This is a pretty big schematic. There it is. They end up over here. And they go through, once again, some other amplifiers over here. And they go through a whole bunch of different level shifters, amplifications, and so on and on. And eventually this amp out comes out, which is used somewhere else in the circuit. But at the same time, we get this out detect. And this out detect seems now to be becoming a little bit more promising. Now, if I were to follow out detect, that will end up yet somewhere else. Let me see if I can find that. Oh no, we're going the wrong way there, so sorry about that. This is a big schematic. So we're looking for out detect here, and it ends up right here. Look at that. It goes through a low pass filter, and it goes through this mux selector and a comparator, and then following that goes through another circuitry over here, and then there is compare. And this compare goes over here, goes all the way out there, and this compare goes through this big ribbon connector again. So now we have to find the ribbon connector again. And if I find that ribbon once again, it is over here, and the compare then comes out, joins this bus, and that goes over here, and then ultimately ends up at the microprocessor. So it looks like that's our best chance. I think compare ends up somewhere over here. I was looking at it just earlier. I'm pretty sure it is somewhere along one of these huge number of signals. But then ends up ultimately here. So this is a good sign. It means that that's what it is using as a self-test. So I went ahead and I modified those potentiometers, which would potentially cause this problem of this intermittent error. And you know what? It seems like it has fixed the issue. So I did it. I ran it a bunch of times, and I wanted to give you just an idea of how I reasoned it out of what it is. It's, it may not be 100% accurate, but it certainly fixes the issue. There it is. There's a compare signal actually comes over here into this and then ends up to the microprocessor. So you can see exactly how it's followed, and there's another error signal right next to it. So indeed, these are both some kind of a diagnostic signal that's being collected. So seems so far so good. So let's go take a look at the instrument. All right, I went ahead and I made the adjustment on the potentiometer, and I ran the self-test about 50 times or so, and I could not get this to fail again. So I think that the repair is definitely working. I know that I went fairly quickly over this last bit, but the repair was actually quite subtle. You had to figure out a couple of little tiny things that would have taken a very long time. I stumbled across them fairly quickly, luckily. But yeah, it looks good. I mean, this is a pretty nice unit. It's a nice synthesizer. It's very accurate. If you calibrate it, it's going to be extremely stable over time because of its oven-controlled crystallizer, and the oven definitely is working, because when I turn it off and I leave it off for quite some time, next time that I turn it back on, I actually get a time-based error here turned on until the oven heats up. And that's a good sign. It means that it's actually working. So that the oven is actually working. It's monitoring the oven temperature. So it looks good, and the frequency is very stable. It barely moves once it's warmed up. So I think it's good. So again, thank you for the people on Patreon. This is the reason I can do this, is because of you guys. So please continue supporting it. And I have a bunch of other things that I want to buy. I continuously check eBay, and I can buy more and more expensive equipment for repair, as I've done in the recent past. So I hope you like it. Give it a thumbs up, and I'll see you in the comment section.